Hello and welcome to Miss Geography. Today we're going to learn how to determine rectangular coordinates and geographic coordinates. Before I start, I would like you to hit the like button and subscribe to our channel for more videos. The rectangular coordinate system. The rectangular coordinate system is used to find locations in two-dimensional plane. Example is the topographical map. Two-dimensional plane is one that just have length and width. This means that if a rectangular coordinate of any point on a plane or a map is known, we can mark the position of that particular point. Understanding the Cartesian plane or the rectangular coordinate in an x and y coordinate system makes it easy to determine the rectangular coordinate in a topographical map. Now, I believe you all are familiar with the x and y coordinates from basic mathematics. But if not, let's refresh our minds before. Now, let's look at the features or the properties of the x and y coordinate or the Cartesian plane. It is formed when two real number lines intersect at a perpendicular angle. The point of intersection of these two lines is referred to as the origin and has the corresponding point 0, 0. The horizontal line is called the x-axis. The vertical line is called the y-axis. The intersection of these two lines creates four regions called the quadrants. So we have the first quadrant, second quadrant, third and fourth quadrant, and it moves in an anti-clockwise direction. On the horizontal line, all numbers from the origin to the right are positive, and the opposite is true for the left. The vertical line also have all positive numbers above the origin, whilst all negative numbers are found below the origin. Now, this is how the Cartesian plane looks like. So we have 1 to 6 on the left, 1 to 6 on the right. We have negatives and positives, and we have the first quadrant, second quadrant, third quadrant, and it goes in an anti-clockwise direction. Now, this is a great form of the Cartesian plane, and it is simple this way because if you want to plot any point given any location, you can easily find it because of the coordinate system that this one used. So for example, we can have 2 on the x-axis and 3 on the y-axis, and it is plotted there. We can also have -3 on the x-axis, and 5 on the y-axis. So it is easy to find locations in the x and y coordinates because of how the coordinates are. Now, on a real map, you can find locations within the grid, and finding just this one coordinate each won't be simple or won't be easy for you to determine the exact location of the point. Therefore, you have to add something, which is the distance to each axis with the x and y axis from the point. Now that we have refreshed our minds on the x and y coordinates and how to find or plot points on it, let's come to the real map rectangular grid system, rectangular coordinate system. Now, the coordinate system also has origin just like the x and y coordinate, and it is formed at the intersection of the equator and the central meridian of a particular zone. So the x and y coordinates have quadrants. The rectangular coordinate system have zones, and each zone also have different grids. And the intersection between the central meridian and the equator is known as the origin. Now you should know that the central meridian are always having conventional values, which is 500,000 meters. I believe I will explain that later on. The rectangular coordinates are determined with the use of grid lines, which are equally spaced vertical and horizontal intersecting lines superimposed on the surface of the map. Each of these lines, is numbered at the edge of the map. So at the edge of the map, you see some marks. So even if the map is not graded, or you don't see the grid being superimposed on the map, you will see some marks at the edge of the map there, and then you will see some figures also right close to it, and those figures are the coordinate numbers for the grids. Now these numbers, the first digit of the number shows the zone number, the particular zone that line falls in, and then we have the distance from the particular meridian of the zone. So we have the zone number and the distance from the meridian. Okay, so there are two types of rectangular coordinate measures. First, is used for relative location or relative position of a particular point that you are looking for. So it will just give you the coordinate to the grid within which the point is found, and that is the 4-figure grid reference system. The second one is the 6-figure reference, and this gives you an accurate location of a particular feature or point in question. So with that, it will give you the coordinates of the grids within which the point is found, and also give you the distance from the point to the x and y coordinates of the grid. Now the steps to determine the rectangular coordinates on a map. Just like the Cartesian plane, the rectangular coordinate system has an origin point, which is the intersection between the equator and the central meridian. Also, it is important to know that the central meridian has a conventional value of 500,000 meters. Therefore, every point at the eastern side of the central meridian has values more than 500,000 meters, whilst points at the western side of it has values less than 500 meters. The first thing you need to do when finding or determining the rectangular coordinates is to find or identify the point in its exact rectangular grid. Identify the value for x and y, which are recorded at the interframe space of the map. Now this point of x and y will give you the direct or the exact location of the particular grid within which the point is found. Once you have identified the coordinates of the grid, you measure the distance from the point to the x coordinate or the x line and the y line using ruler. When you are done with the measurement, you convert the map distance onto actual ground distance using the scale of the map, and then you finally add those distances to their respective x and y coordinates, and the rectangular coordinate of the particular point is found. So this is a map I made myself using ArcGIS. It doesn't look so good, but you can use it to demonstrate how to determine geographic coordinates. So on this map, we have grids which are superimposed on the map. We have the vertical and horizontal lines. Each line has specific numbers added to them at the edges, but they are not so visible, so I just zoomed in. I just enlarged the ones that I'm going to use for the demonstration. So you see that we have y equals to 7243440, and then x equals to 2476170. And we also have indicated the point that you are going to find its location with a red arrow, and I have used and assumed distances in centimeters to represent the distance from the point to the x line or the meridian, and the point to the y line or the longitude. So we're going to look at how we will find the coordinates of this point. So going forward, we're going to assume that the map scale is 1:25,000, and we're going to find the location of the point with a red arrow on it. We also have the x and y coordinates for the grid, within which we can find the point. So the x value or the x coordinate is 476,170. So you see the 2 is in brackets. That 2 represents just the zone. It doesn't really represent, or it's not part of the distance, so it just represents the zone. And y also, we have 243,440. Now the 7 is also not going to be a part of the distance from the central meridian to the grid, so you eliminate or you exempt that when you are finding the difference between the distance. And we also have the distance from the point to the grid, the x and y, which the distance from the point to the grid on x axis is 1 centimeter, and then on y axis is 2 centimeters. You also have to note that the central meridian has a value of 500,000 meters. Now we know already that the first digit of the x value, which is 2, is just the zone number. So finding the distance from the central meridian to the grid, we are going to subtract 500,000 meters from 476,170, which is going to give us 23,830 in negative. We can also convert that into kilometers and show the western side, and then we eliminate the negative sign. So you're going to have 23.8 kilometers west. That means that this particular grid is located or is at a distance of 23.8 kilometers from the central meridian. Okay, so finding the exact location of the points using the scale of the map, which is 1:25,000. So you're going to find for x, we know that the distance from the point to the x-axis is 1 centimeter. Therefore, we are going to convert that 1 centimeter into actual ground distance. So So we're going to multiply 1 by 25,000 centimeters, which is going to give us 25,000 centimeters. Then you convert it into meters, which is 250 meters. So therefore, the new coordinate for x is going to be the old coordinate plus 250 meters, which is going to give us 2, which is the zone, and the 460,420 meters. That is our new coordinate for the x-axis. And on the y-axis too, we're going to multiply the 2 centimeters, which is the distance from the point to the y-axis, by 25,000 centimeters. Now, when you get your answer, which is 550,000 centimeters, you convert it into meters, which is 500,000 meters. So our new coordinates is going to be 7,230,940 meters. Therefore, our rectangular coordinate for the point is found. Now, determining geographic coordinates. Geographic coordinate system expresses location with the use of coordinates of latitude, which is the north or south horizontal lines, and longitude, which is east to west vertical lines. The geographic coordinate system is expressed in degrees, minutes, and seconds. Therefore, the geographic coordinate of a point can be expressed as 20 degrees, 15 minutes, 20 seconds to the south, and 160 degrees, 40 minutes, 10 seconds east. Finding the geographic coordinate of a point on a topographical map is very simple. First, you have to locate the point on the map, then draw dotted lines of latitudes and longitudes from the point to the edges of the map. Finally, using your degrees, minutes, and second divisions on the edges of the map, you can determine the coordinates of the map. Thank you so much for your time. I hope you enjoyed the video. I'll see you in the next tutorial section. Have a nice day, and please like our video if you enjoyed it. Bye bye.